Okay, today we're going to talk about solving linear inequalities in a single variable. There are two types of notation for graphs of inequalities: open circle or filled in circle notation and interval notation brackets. You should be familiar with both. Here we have x is greater than or equal to a -1. So there's two types of notation. There's a circle notation there. See, everything is bigger than a -1. And you can see the equality symbol. The circle is -1 is included as part of the solution set. On the other side here we have a bracket notation. We see that -1 is included as part of the solution set. Both of these number lines show the inequality above. They're just using two different notations. Because the inequality is greater than or equal to, the solution can equal the endpoint. That is why the circle is filled in. With interval notation, brackets, a square bracket means it can equal the endpoint. Circle filled in, the bracket, squared in bracket, means you can't include that point as part of the solution set. Remember, these mean the same thing, just two different notations. Let's look at the two different notations with a different equality sign. In this case here, -1 is the largest thing on the interval. Using circle notation, we do not include the -1 as part of the solution set. Using bracket notation, it approaches -1, but -1 is not included as part of the solution set. Since this says strictly less than, we make the arrow go the other way. Since it doesn't say or equal to, the solution cannot equal the endpoint. That is why the circle is not filled in. With interval notation brackets, a rounded bracket means it cannot equal the endpoint. It doesn't say or equal to, so -1 is not included as part of the solution set. Remember, these mean the same thing, just two different notations here. Next topic, compound inequalities. Let's consider a double inequality having two inequality signs. When we look at this, we see x is greater than a -2, and at the same time, x is less than or equal to a +3. Here we have circle notation, and we have bracket notation. Notice the negative here, we have the strictly greater than, and on the endpoint, -2 is not included. And over here we have possibility it could be equal to, so the endpoint is included. These brackets here tell the behavior of the endpoints. And on the circle notation, it does the same thing. It tells the behavior on the endpoints. I think of these as in-betweeners. X is in between the two numbers. This is an AND inequality, which means both parts must be true. It says that x is greater than -2 and x is less than or equal to 3. Compound inequalities. Let us look at another form of a double inequality, having two inequality signs, that is. In this case, x is less than a -2, or x is greater than or equal to a +3. Here we have it being represented in circle notation. Here we have it in bracket notation. Notice that it's disconnected, meaning that because it's disconnected, we have an OR statement here to join the solution set. Since it cannot be true both cannot be true at the same time. Instead of and, these are OR problems. One part or the other part must be true, but not necessarily both. Either x is less than -2, or x is greater than or equal to 3. In this case, both parts cannot be true at the same time, since a number can't be less than 2 and also greater than 3 at the same time. Just like graphically, there are two different notations. When you write your answers, you can use inequality notation or interval notation. Again, you should be familiar with both types of notation. Here you can see that x is greater than or equal to a -1. So in this case, -1 is part of the solution set. And over here we have, on the endpoints here, we have a -1, which is included, and it approaches infinity. Since infinity is never attained, it is always have an open bracket there. See, these symbols with the bracket notation tells us the behavior of the endpoints, whether or not to include or not to include them as part of the solution set. Here we have inequality notation for graphs shown above. Here we have interval notation for the graph shown above. Now let's have a look at interval notation. See, it tells us the behavior. The bracket tells us the behavior of the endpoints, whether or not to include them as part of the solution set. For interval notation, you list the smallest x can be, then a comma, and then the largest x can be. So the solutions are anything that falls in between the smallest and the largest. This means that x is unbounded above. We never reach infinity. There's always one more larger number. And it goes on forever in that direction. There's a -1 and there's infinity. Okay. The bracket before the -1 is square because this is greater than or equal to. Solution can equal the endpoint. The bracket after infinity sign is rounded because the interval goes on forever. It's unbounded. And since infinity is not a number, it doesn't equal the endpoint. There is no endpoint because it goes on forever. Let's try another one. Here we have our interval notation. Notice what the symbols are being used. We have an open bracket that's open on one end and closed on the other. So that tells the behavior of the endpoints, which ones are included as part of the solution set. This means everything between -2 and 4, but not including -2. rounded bracket means it can't equal -2. Squared bracket means that it can equal 4. The brackets used in interval notation are the same ones used when you graph this. There's your open parentheses, and there's your bracket there. Here's another one. It's open on both ends, and we have a negative infinity, and we have a 4. So reading it from left to right, the smallest number is at negative infinity, meaning it's unbounded. It goes on forever down on the low end, and on the top end it approaches 4, but does not include 4. This means the largest x can be 4, but can't be equal to 4. On a number line, we have here open bracket, and it goes down to -4 here. All the way down to negative infinity. Notice how the bracket notation for graphing corresponds to the brackets in interval notation. This makes it easy to remember. Remember that a square is round, and round is up to but not equal. So what they're saying here is that remember that a bracket means you include the endpoint, and with an open parentheses there, it approaches it but does not include the endpoint. So, as I said before, when you have interval notation, the symbols on the ends tell the behavior of the endpoints. Here's a compound inequality. We have x is less than -2, or x is greater than or equal to +3. There are 2 intervals to list when you list this solution set here in interval notation. We have two sets here. We have to talk about both of them when we talk about the solution in this case. In interval notation, open, because you never approach infinity. On the other side, we have the bracket 3. We include 3, and it goes to positive infinity. So we have to join these 2 sets as part of our solution set. We use a union sign to describe that. Properties of inequalities. Essentially, all of the properties that you learned to solve linear equations apply to solving linear inequalities, with the exception that if you multiply or divide by a negative number, you must reverse the inequality. So to solve an inequality, just do the same steps as with equality to get the variable alone. But if in the process you multiply or divide by a negative number, let it ring out alarm in your mind that says, oh yeah, now I have to reverse the inequality. Keep it true. For example, here, we have to get our variables on one side. So I subtract 4x on both sides. Now I have -2x minus 6 is less than 8. I add 6 to both sides to get the variable by itself. Now I have -2x is less than 14. So I want to get x by itself, so I have to divide by a -2. That's right, there's an alarm. We divided by a negative. So now we have to reverse the inequality. X is greater than a -7. We reverse the symbol here, the inequality symbol. And that concludes this presentation. Have a great day, everyone.